How's it going, guys? This is question number 17 on the WebAssign. A 1,285 kilogram car moving north at 27 meters a second is struck by a 2,165 kilogram car moving east at 16 meters a second. The cars are stuck together how fast, and in what direction do they move immediately after the collision? Now what's important is first you have to draw this triangle correctly, right? And in order to draw the triangle correctly that I drew up here, you have to follow a certain method. So, and most of the time in questions like these, they're going to give you two directions. They're going to give you like one car is moving south, one car is moving north. The way I do it is I always draw the second direction first. So in this question they asked a car moving north, and then they said a car moving east. So I drew the east arrow first, and then I drew the north arrow. Now what this basically allows me to do is, it allows me to like figure out the directions, the angle easier. So like if they ask me what is like north of east, like in this question they ask how many degrees north of east, right? Is the thing. And it would be a lot like more difficult if I drew the arrow in a different way. It would just be more conceptually different to understand. So that's why I'm drawing it in this way. Now, what you're first going to do is you're going to find the momentum of both of these sides, because you know the car is, you know how heavy the car is and you know how fast it's going. We're using the momentum is equal to mv equation. Well, and we're doing all that so we can find the total momentum of the collision, which is actually just the hypotenuse, right? Total momentum of the collision is the hypotenuse. So I already did the math here, because I don't really want to like pull out my calculator and like wait like 5 minutes because I'm typing too slowly to do the math. Okay, so once you get these two numbers, you're going to plug it into the Pythagorean theorem, because we're trying to get C, right? I'm just going to make this C, because this is A, B, C. So we're going to do 34,695 squared plus 34,640 squared is equal to C squared. Now let me plug that in. Plus 34,000. And remember to square root the C once you get to it. I got C is equal to 49,027.26 kilograms times meters a second. As you might have noticed, I put kilograms times meters a second over here as well. It's a continuity because momentum is always in kilograms times meters a second or newtons times second. And in this version, it's in kilograms times meters a second. Why? Because, I mean, this is 2,165 kilograms. This is 16 meters a second. Guess what? You multiply kilograms and meters a second. That's why the unit is there. So that's C. Now what you're going, because now that is the total momentum of the entire system. And it says the cars are stuck together after the collision. So what we're going to do now is, we are going to add the masses, because both the cars are stuck together. So 2,165 and 1,285 should be added together. 2,165, 1,285. Times V, because I'm using the momentum, times the velocity equation, is equal to this. There's a bit of a gap, but it's fine. I'm not going to try to correct that. Now you just simply plug that in to your calculator. And your velocity is equal to 14.2108 meters a second. And that's your velocity. So that's going to be your answer for the second part. And for part A, you're going to find the degree, right? So now you got the question. What angle should I find? Oh God, this marker is running out. Should I find this angle or this angle? Now it's asking for how many degrees north of east. So, I mean, if I draw a compass, let's say, okay, let me just draw a compass. North, south, west, east. Now, north of east would be what? Like this, right? Like if I drew a triangle, this would be north of east, right? Yeah. So on this triangle, and then this is why I use the triangle rule that I was telling you about, that you always draw the second, the second direction first. Because guess what? It's so easy to find north of east now. We just know, based on this compass, that it's got to be this, right? And I'm sorry, like the marker is like smudging a lot. I don't know what's happening there. Yeah, it's kind of dying. Okay. So I'm gonna make this theta. That's like the symbol for degree. So I'm gonna erase this so I have more board space. And now we're gonna try to find theta. We're gonna do some trigonometry. Now, because some of you might be new to trigonometry, but it's a very fairly simple equation that you just need to know for these types of questions. So this is tangent theta is equal to opposite over adjacent. Right? Now that means the opposite side and the adjacent side. The adjacent side can never ever be the hypotenuse. Let me write what C was over here. 2,6. Right? So now we're going to plug that in. We're going to do tangent theta. Tangent theta equal to 34,695. Oh yeah, you're not ever going to plug into this equation this or this. You're always going to plug in the total momentum. Because I mean, that's what we're trying to find. We're trying to find the theta between these 2 points. We're not trying to find the theta between the two masses or something. We're trying to find the angle between these two momentums. 34,640. Now, you know, as you can see, these numbers are fairly similar. So you would expect an answer of close to 1, right? If you think about this logically. And there you go. Your answer is going to be very close to 1. Your answer is going to be tangent theta is equal to 1.002. Right? So now we're going to do. Now you might have realized, right, that we're trying to find for theta. We're just trying to find for theta. And so why is there a tangent in front of it? Well, the thing is, we actually need to get rid of the tangent. So what we're going to do is we're going to divide a tangent, right? And a critical principle to understand here is that there's a thing called exponent rules. So if I had 1 over sine, right? That is the same thing as sine to the negative first power. If I had 1 over 4, that's the same thing as 4 to the negative 1 power. So it is the exact same thing with tangent. With tangent, I have something over tangent. So yeah, it doesn't particularly have to be 1. But I have something over tangent, so I'm going to do tangent to the negative first power, and I'm going to multiply that by 1.002. Maybe put this in parentheses as well, so it doesn't mess up anything on your calculator. And then I can get theta. Okay? So now you're going to plug the tangent to the negative 1 power on your calculator times 1.002. And I think I think it's necessary for you to use a calculator on this, because it would be extremely, extremely difficult for you to do this otherwise. I think it's fairly impossible, really, if you don't have a calculator for this. And this is your final answer. It's 45.057 degrees theta, and that's how many degrees north of east the cars move immediately after the collision.